Assalamu alaikum, dear students. In this lecture, we will be discussing exercise number 2.3. That's based on the concept of functions. So first of all, we will be discussing what's function, and after that, we will be solving the exercise based on the functions. So first of all, let's understand what's function. As I have already discussed, that if you have two sets A and B, then we have different operations on these sets A and B, and one operation is cross product, and any subset of that cross product, that's called a relation. Now the function is actually a specific type of relation. So what type of relations they are? We are going to learn those type of relations here in this lecture. So a relation f from a set A to set B is said to be a function if every element of set A has a unique image in set B. Most important points that are here in this definition, there are two. That is, one is every element of set A. Every element of set A that should have a unique image in set B. That is one and only one image in set B, unique image in set B. Such a type of relations are called functions. Okay. Rest, domain, and range, we have calculated in the relations, and some is the procedure here. So let's go to the exercise number 2.3. We will be checking here which of these relations are functions. First of all, in the first part of this question, that is given by 2, 1, 5, 1, 8, 1, 11, 1, 14, 1, 17, 1. Here, every element, that's 2, 5, 8, 11, 14, 17, they have a unique image. Unique does not mean that they should have separate images. Unique means they have only one image, and that one image may or may not be different for every element of the domain. Okay, so in this first part, every element, every domain element, that's 2, 5, 8, 11, 14, 17, they have a unique image. They have only one image, one and only one image. They don't possess two images. So this is a function. And if this is a function, what is its domain? Domain is a set of first entries. So the first entries are, they are enlisted here. So this is the domain. And what is its range? That is set of second entries. Set of second entries is 1, 1, 1, 1, and will not be repeating as per the set rules. So this is 1. Range is a singleton set 1. Same is the part number second. Yes, it is a function. And in this function, you can write the domain and range. I have written it here. Next is part number third. It's 1, 3, 1, 5, 2, 5. So what is in this function? What's in this relation? You see, it's 1, 3, it's 1, 5, and 2, 5. First of all, we will check whether every element has a unique image. See, 1 has image 3, 1 has image 5. So there's one element, that's one of the domain, this one of the domain, that has two images, 3 and 5. Two images, 3 and 5. So if it has two images, 3 and 5, so it is not a function because there is one element in the domain that has two images. So it's not a function. Now let's see question number 2. In the question number 2, we are given two real functions. That's f of x is equal to minus times modulus of x. We have to find its domain and range. We know that modulus of a function is defined by, in this way, it is x when x is greater than or equal to 0. It's minus x when x is less than 0. What is actually modulus? It actually filters the negative sign. When it is positive, it keeps it positive. When it is negative, it assigns one additional negative sign. That is this negative sign with it, and it becomes, with the help of this negative sign, positive. Okay. So if we are supposed to write minus times modulus of x, so minus times modulus of x is like this. We have to assign negative sign with this and this as well. So it will become minus, it will become plus. So what can we understand? It was supposed to filter the negative sign. Now it will not filter the negative sign. It will associate the negative sign with every element. So earlier, we were supposed to obtain the positive numbers. Now we are supposed to obtain or get the negative numbers. So since the f of x is defined for x belongs to R, the domain of f is the real numbers. But what about the range? Range is not the whole real number. Range is the set of negative numbers, that is from minus infinity to 0. Next is part number second. In the part number second, here part number second, let's see here, it is f of x is equal to under root of 9 minus x square. First of all, we will see for what values of x this f of x is defined. Since these are real functions, so for what values of x it will be real. So we can check that it will be real for all those values that lie between minus 3 to 3. Yes, you can see it here. For all those values lying between minus 3 and 3, the function will be a real function. So this will be its domain. It will assume all the values between minus 3 and 3, and minus 3 and 3 included. So it will be its domain. So what is its range? Range is the values of range is the set of values obtained by putting the values of domain in this function. So if we will put the values from minus 3 to 3 in this function, for example, we will put it here 0, it will be 3, 1. Accordingly, we will get a real number. 2 will get a real number. 3, we will get 0. And if we go on negative sign, some procedure will happen because due to the square sign. So what values we will get? We will be getting the values from 0 to 3. So this is the range set. Okay, this is the range set of this function. So in this way, we can calculate the domain and range. Hope you have got it. Thank you for joining the class. Thank you once again.